Hello guys, welcome back to Clinically Clear. So today let's cover air pollution. So air pollution, basically the basic requirement is there should be 3000 cubic feet of air per hour, and there should be 2 to 3 air changes per hour. Basically it shouldn't be stale air. There should be a few changes in the air. Neither should it be very windy as well. Like it's extremely windy, then also it's not good. So, what are the sources of air pollution? Common sense, industries, automobiles, domestic sources like burning firewood, agricultural stubble burning, human habits like tobacco smoking, all these are sources. Now, coming to the air pollutants, you have primary pollutants and secondary pollutants. Primary pollutants, they are directly coming from the source. Carbon monoxide. Carbon monoxide is very poisonous. It can cause fatal poisoning. Carbon dioxide causes global warming. Methane causes global warming. Nitrogen oxide and nitrous oxide and nitric oxide, they are mainly from automobiles. So automobile exhaust pollution indicators are nitrogen and nitric oxide. Sulfur dioxide is an industrial air pollutant. So industries meaning sulfur dioxide. Chlorofluorocarbons, they also cause global warming by ozone depletion. And one very important primary air pollutant is polycyclic aromatic hydrocarbon. These are from firewood burning, from tobacco smoking, all that leads to polycyclic aromatic hydrocarbons. You have example benzoapyrene, you have benzanthracene, naphthalene. Benzopyrene is the most dangerous out of all the polycyclic aromatic hydrocarbons, but these are very carcinogenic and they cause many respiratory disorders. So these are the primary air pollutants. Each have their own significance. Carbon monoxide, carbon dioxide, methane, nitrous oxide, nitric oxide, CFC, sulfur dioxide, polycyclic aromatic hydrocarbons. Secondary air pollutants, they are formed from primary air pollutants. Okay, smoke, dust, ozone. Ozone is the best indicator for secondary air pollution. It is formed from primary air pollutants due to a photochemical reaction induced by sunlight. The primary air pollutants and the oxygen in the air, they react, they undergo a photochemical reaction due to sunlight to form ozone. Smog is smoke plus fog. Acid rain is also a sort of a secondary air pollutant. It's not exactly an air pollutant, but when water combines with nitrogen oxides and sulfur dioxide, you get acid rain. So smoke, dust, ozone, smoke. The best indicator for secondary air pollution is ozone. Ozone should be less than 100 micrograms per meter cube. Important. Ozone should be less than 100 micrograms per meter cube. Then coming to effects of air pollution. On health, you can have acute effects. Like it can cause irritation to the eye, conjunctivitis, irritation to the nose, allergic rhinitis, throat, pharyngitis, bronchitis, exacerbation of asthma, exacerbation of COPD. Carbon monoxide poisoning can lead to asphyxial death. So these are all the acute health effects, acute respiratory conditions. Chronic respiratory conditions. Long-term air pollution can cause COPD, emphysema, and chronic bronchitis, asthma, lung cancer, suppurative lung disorders like bronchiectasis and lung abscess. So these are all the health effects. Respiratory, think respiratory air pollution, so respiratory, acute and chronic. Socioeconomic damage, it causes damage to flora and fauna. Think about the movie Interstellar. Because of the dust storms, the only thing they're able to grow is corn, all other crops have died. Damage to buildings, think about the Taj Mahal. Taj Mahal once upon a time used to be white in color because of the limestone. Because of sulfur dioxide pollution, it has turned yellow in color. Poor visibility, think about cricket matches that happen in India. In Indian stadiums, the visibility is so poor. Whereas if you compare the broadcast to some a match taking place in England or Australia, it is so much better. So poor visibility. So these are the socio-economic effects. And global warming is a very important effect. Climate change, carbon dioxide, chlorofluorocarbons, methane, they all contribute to global warming. Now, excess greenhouse effect leads to global warming. Global warming. Excess greenhouse effect and ozone depletion. Greenhouse effect in itself is not a bad thing. Greenhouse effect is a normal thing. Without greenhouse effect, our planet won't retain any heat. So to maintain atmospheric temperature to sustain life, we need greenhouse effect. And greenhouse effect is more contributed by water vapors than even carbon dioxide. But what happens because of rising carbon dioxide, CFC and CH4, it is leading to global warming. Okay. So health effects, socioeconomic effect, global warming effects. Now high altitude, this is not air pollution exactly, but at high altitude what happens? Temperature is less, so there's a risk of hypothermia. Atmospheric pressure is less, so partial pressure of oxygen is also lesser than 60 mm of Hg. That can lead to hypoxia, hypobaric hypoxia because of low oxygen partial pressure. Humidity is less at high temperature, so there is a lot of insensible heat loss and water loss. It's not, it's more of water loss, insensible water loss that can lead to dehydration. So how do we measure the atmospheric pressure? Through barometers. Barometers, you have aneroid barometers, where the principle is based on metal expansion, but aneroid barometers, the problem is they're not that accurate. They require more maintenance, calibration, all that. Mercuric barometers are the best, where 760 mmHg is equal to 1 atmospheric pressure. Okay, leave that. This part is actually not that important. Then coming to the monitoring. Monitoring of air quality, air parameters is done by the Central Pollution Control Board, CPCB, which comes under the Ministry of Forest, Environment and Climate Change. So CPCB is under monitoring. So sulfur dioxide index for industrial air pollution, indicator of industrial air pollution. Grit index, indicator for dust, basically solid particulate matter, dust, sand, all these kind of things. Grit index, soiling index, it is an indicator of smoke. Biological indicator is lichen. Wherever lichens used to grow before, now they are not growing. Why? Because of air pollution. So biological indicators lichen, and the most important, so you have sulfur dioxide index industrial, grit index for dust, soiling index for smoke, and biological lichen. And the most important air quality indicator is AQI, air quality index. This takes 8 parameters into account: industrial, sulfur dioxide; automobile, nitrous and nitric oxide; dust in the form of particulate matters. You have PM10, PM2.5. Particulate matter 10 micron size, particulate matter 2.5 micron size. Ozone, secondary air pollution. Metallic, lead gas, metallic. Ammonia, organic. And the most dangerous, I told you, most poisonous, carbon monoxide. So it takes these 8 into account. Air quality index takes the presence of these 8 gases, these 8 air pollutants. It does not take a CFC, CO2 or methane. None of the greenhouse gases, none of the global warming gases are taken into account. No CFC, no CO2, no greenhouse gas. Okay. Air quality index of Mysore is around 40. So 0 to 50, it is a good AQI. 50 to 100, satisfactory. 100 to 200, poor. 200 to 300, very poor. And 300 to 400 is severely poor AQI. So this is how we monitor air quality: CPCB, SO2 index, grit index, soiling index, biological indicators, and AQIs. Prevention and control of air pollution. Now, this is a very, it's like a social science topic. So, containment. Basically, we don't want the air pollutants to escape into the atmosphere, right? So, what we do is we keep it all in enclosures. We do all the incineration, all the hazardous processes in enclosures, and anything which we have to let out of that enclosure, we filter it and we make sure that it is well ventilated. So this is to prevent the escape of pollutants into the atmosphere. That is containment. Then coming to dilution. Dilution, what basically, we place a green belt of trees around industries, so that as the pollutants move from industries to the homes, they get diluted along this green forest belt. That is dilution. Replacement. Replace fossil fuels with sustainable energy sources like solar, CNG, and nuclear energy. Legislation. Air Pollution Control Act 1981, Air Pollution Prevention and Control Act 1981 was passed in India. Community awareness. Build community awareness about air pollution, the ill effects, how to improve air pollution, how you can make a difference. Social science. International cooperation, like 1997, Kyoto Protocol was signed upon, which said all the countries have to reduce greenhouse gas emissions by 18%. So that was Kyoto Protocol. 2016, there was an update known as Paris Agreement. 2016 Paris Agreement said, along with reducing greenhouse gas emissions to decrease global warming, we have to switch over from fossil fuels to renewable energy sources. That is Paris Agreement. So just reducing greenhouse gas emission, Kyoto Protocol. Paris Agreement, switch over to renewable energy sources. So prevention and control, containment, dilution, replacement, legislation, international cooperation, and community awareness. That is it about air pollution. Short topic, but it can be asked. Thank you for watching.